Hi everyone. In today's video, we are going to talk about RAG architecture and we'll try to decipher the end-to-end architecture, end-to-end pipeline of RAG, how we connect different data sources to the large language model, and then how we can interact with that particular knowledge base. For example, right now, what I have done is I have ingested a file and I'm talking with that file information using this application, right? And I'm using large language models. So right now in this example I have used tiny llama, but this Mistral is also connected here. Zephyr is also a part of this application. Then there are different DBs which have been created. The connected DB is Chroma DB 550. I'll talk about what these numbers are, and then on the fly, if you want, we can ingest few more files and create a knowledge base using this application, right? So that's it. Let's go to the OneNote and try to understand what RAG architecture is and how it works. So in RAG architecture, the assumption is that you are basically plugging a knowledge base to your LLM. Okay, and then you can chat with your LLM regarding the knowledge base which you have attached. Okay, so for today's example, think of it like we have certain files. Okay, so these files can be of any format. So think of it, it could be PDF or PPT, or it could be a text file. Okay, so what happens in rack is that there are different components. One component is basically um, the text extraction. Okay, so all these files, so there can be one file or there can be many files. Okay, and all those files can be of different formats. But the common thing is, the common intention here is that we are fetching the textual data from these files. Okay, so we are fetching the textual data from these files. Now there can be many ways to extract this. Okay, I'm not going into much deep, but think of it like you can use, if it is PDF, then you can use mu PDF, right? If it is PPT, then you can think of a different kind of package which will extract textual data from PPT or TXT and so on. Okay, now there's one more concept also in extraction, is that, for example, think that you have a PDF. Okay, and that PDF might have 1,000 tokens. Okay, but your extraction logic is that in one chunk you are basically having only 500 tokens. That means when you will extract the data and convert it into a chunk, it will be having two chunks. Okay, and chunk is nothing but when you are extracting the textual data, in one chunk how many words or tokens should be captured. Okay, so for the time being, let's say that our standard chunk size is 500 tokens. Okay, so in single PDF there will be 500 tokens. Here also it will be 500. Here also it will be 500 for each and every token. So if let's say this is 1,000, then it will have two chunk, right? If there is 500, then there will be only one chunk, right? And then if it is 100, then here also there will be only one chunk, right? I hope you understood the logic here. I'm going to rub all these information just to keep the things simple. Okay, I'm going to rub all these things also. Yeah, so next step is basically the embedding part. Okay, so embedding is where you are converting your words into embedding. So let's say, for example, if hello is the word, then it gets converted into the embedding. Okay, so this is the vector representing the hello world. Fine, let's go ahead and understand how the flow will go on. So this is embedding. After embedding, all these embeddings get saved into a vector store. So this is the vector store where vector db, you can say, where all these embeddings will get saved. Okay, so think of it, these are all vector which are getting saved. Now you can say that this whole architecture is complete. This is the whole architecture. But think of it that once your architecture is ready, user is coming. This is the user, and it want to basically interact with this knowledge. Okay, and so these PDFs could be of any domain. So think of it, these are biological papers where we might have different type of content in it. Now what happens is when it asks a question, that question is basically a prompt. Okay, so and the question could be as we said, it's a biological paper, so think of it like very simple. What is biopsy? Okay, um, this prompt gets converted into the embedding. Okay, why it's getting converted into embedding? Because all our data is converted into embeddings and then it got saved to data, the vector db. Okay, so this embedding is the same embedding which we have in our pipeline in our architecture. Okay, so this one and this one is same, just because I'm explaining it as pipeline, so I'm just explaining it for the sake of simplicity. Okay, so these embeddings then goes to the vector db. Again, this vector db is the same vector db which I have defined here, vector db, and then a similarity search will happen. So once the similarity search will happen, let's say let's say we have some vectors, some PDFs or whatever it is, which is related to biopsy, and it has some biopsy related information. So what will happen is that those chunks, again, as I explained you before, right? I mean, all these textual data will get converted into chunks, and those chunks will converted into the embedding, and then that embedding will get saved to the vector db. So what will happen is we will get some similar chunks where the biopsy information might be discussed or might be present. Okay, so all these matching papers or chunks will now work as a context. This is the context. Okay, and then we have the question from the user, right? So what is biopsy? So question is what is biopsy, and then we have a context. So these two things now will go to the LLM, large language model. Okay, from the LLM. Now, LLM could be any LLM, right? I mean, as I have shown in my setup, what I did is I have taken the tiny LLM, and in that tiny LLM, I have some configuration which I'll show you going forward. Okay, but think of it like you have the question, you have the context. Now you are asking the LLM that okay, I have this question, and I'm also giving you a context. Okay, what is context? It is a set of chunk where the where the biopsy information is there. Now what LLM will do is basically it will generate an answer, and this answer goes back to the user. So guys, I hope I have explained the RAG architecture well. Just wanted to add one more thing on top of this is that whatever I have shown, the pipeline, it's the bare minimal architecture where we have not included any kind of improvisation or improvement in any of the component. So going forward in the videos, in the other videos, I'll try to come up with different techniques with which we can work on the text extraction part, embedding. There are many different types of embedding. I'll try to include that part also. There are vector DBs, different vector DBs. So in this example, I'm using Chroma DB, but there is Pinecone, there's Face, and there are different other options to to work on the vector DB. And there are many ways to improvise the retrieval part also. So all these components which we have talked about today can be improved depending on the use case we are working on. Okay, so please stay connected, subscribe to the channel, and because today was my first video in this channel, so I'll try to improve myself and try to cater much more information and informative videos going forward. Thank you.